Today we will continue to talk about data structures. So today we will focus on another type of data structure, which is linked list. So first, what is a linked list? A linked list is a linear data structure in which the elements are not stored as contiguous memory locations. The elements in a linked list are linked using pointers as shown in the below image. Okay, come in please. Neil. Take a seat.
Okay. I'll listen to this part. Sorry, I'm late.
So here is a picture to represent the structure of a linked list. So we can see that here are several nodes which can store data and their reference to other nodes. And this is the head node which points to the first node in the linked list. Okay. So for node structure, a node in a linked list typically consists of two components. First is data. It holds the actual value or data associated within the node. So the next is called the pointer. It stores the memory address, which is reference of the next node in the sequence. So we can only access the other node using the pointer from the node before it. So this is very different from the array we talked about, because you can simply use indexes to access to every element inside the array, but in the linked list you have to use pointers to access the node after the current node. So for head and tail, then the linked list is accessed through the head node. So you can only reference to your current linked list through the head node. And this head node points to the first node in the list. And the last node in the list points to null, or indicating the end of the list. This node is known as the tail of the linked list. Okay. So now we'll talk about why linked list data structure are needed. So here are a few advantages of linked list that is listed below. It will help you understand why it is necessary to know. So first, linked list is a dynamic data structure. So it means that the size of the memory can be allocated or deallocated at runtime based on the operation insertion or deletion. And this is very different from the array data structure we talked about last time, because for an array, you must define its size at the very beginning when you define this array. So you cannot easily modify the memory limit of the array. But for the linked list, the size of the memory is not fixed, which means that its size will change as you add or delete nodes from the linked list. And for the linked list, its insertion and deletion are also very different, because if you want to insert or delete the nodes from the beginning or the end of the linked list, is very simple, because you don't need to move the elements inside the data structure. And the memory utilization is also very efficient, because you don't need to predefine the capacity of this data structure, so you will not waste your memory at the beginning of initialization. And there are very different kinds of implementations of this data structure, which we will talk about in detail later. So here is an example of an linked list. So here first we have a list of IDs in an array, and we suppose that it is in a linked list type, and then we can show that it's very efficient to delete or insert an element, because, for example, if you want to insert a new ID with value 1005, so we must insert it here. And if it is an array, we must move all the elements here backwards, so we can have a new space here, and then we can put the 1005 here. But if this is a linked list, we can just modify the references, and we can just point 1000 to this, and then point this to 1010, and then we have successfully inserted this new element. So in a lot of cases, it is very simple to insert or delete a new element. Okay. So here are the three common types of linked list, which are single linked list, double linked list, and circular linked list. So for single linked list, each node contains a reference to the next node in the sequence. So this is the type of linked list we talked about like a moment before. So it is in a lot of cases the most commonly used one. And for double linked list, so a node contains references to both the next and previous node. So this means that, for example, when you are currently at this node, you can traverse from this node to this node, and you can also access the node before it because you also have a reference to it. And the last type is circular linked list. So in a circular linked list, the last node points back to the head node, creating a circular structure. It can either be singly or doubly linked. So here are some advantages of linked list. So we have talked about this just before, so we will skip this. And now we'll talk about some disadvantages of linked list. So the first is random access. So unlike arrays, linked lists do not allow direct access to elements by index. So traversal is required to a specific node. So for example, if we have a linked list here, and if we want to get the value of the last node, if it is an array, we can just use the index of the last node, last element to get its value. But if it is a linked list, we have to traverse from head and the next node, and finally points to the last node in the linked list. So in some cases, it is very inconvenient to traverse the whole linked list and will cost more time. And the next disadvantage is extra memory, because linked lists require additional memory for storing the pointers compared to arrays. So in some cases, if you know initially that your space of memory needed will be this large, and then you can use an array because it needs less memory to store the pointers. So here are some applications of the linked list. So linked lists are used to implement stacks, queues, graphs, and a lot of other data structures. So it is also used in the link allocation of files. It helps in memory management, and linked lists are used to display image containers. Users can visit past, current, and next images. So if you visit your your photos in, for example, your phone, your cell phone, and this is implemented by linked list because and it's typically a double linked list because you can access the previous image and the next image from the current image. And linked lists are also used to perform undo operations. linked lists are also used in software development, where they indicate the correct syntax of a tag. And linked lists are also used to display social media feeds. So for linked lists, they are very commonly used as a data structure. So next we'll talk about the Java code for linked lists. So the first code is to create a node. So we have a class called linked list here, and we have a node type called head, and then the node is also a subclass. It has two fields. The first is data, which is an int type, because we are supposing that we are storing int type information inside our linked list. And then the other field is a node type called next. So you are storing the information of the next node inside here. So it is a very excellent kind of design, because with the node type you can just visit the other node here. So this is, I think, very different from, for example, C++ language, because they have a predefined STL inside. So they do not use this type to define a node. And here is the node constructor. So this is how you create a node and pass in the initial values for this node. So it is the initialization part here. So this D is the inside value of the node, and initially the next reference will be set to null. So after defining our linked list, we are here to talk about the operation of insertion. So given a linked list, the task is to insert a new node in this given linked list at the following positions. So there are three possible or potential positions that we will insert a new element. The first is at front of the linked list, and the second is after a given node, and the last is at the end of the linked list. So now we will talk about how to insert a node at the front or beginning of a linked list. So to insert a node at the beginning of a list, we need to first make the first node of the linked list linked to the new node. So now the head will not point to this node. Instead it will point to this new node. And then and then we will remove the head from the, so first we will make the first node of the linked list linked to the new node, and then we will cancel this reference and let the head node point to this new node. So at last we will just let the new node as the head of the linked list. So then we will finish inserting a new node at the front of the linked list. So here is a code to push a new node into at the front of a linked list. And then we will talk about how to insert a node after a given node in the linked list. So to insert a node after a given node in a linked list, we need to first check if the given node exists or not. And if it does not exist, we will terminate the process. So if the given node exists, we will first make the element to be inserted as a new node. So we will first initialize this element or this new node, and then we will change the next pointer of given node to the new node. And last, we will now shift the original next pointer of the given node to the next pointer of the new node. And here is also the Java code for inserting a new node, like in the middle of the linked list. And last, we will talk about how to insert a code at the end of a linked list. So to insert a node at the end of a linked list, we need to first go to the last node of the linked list. Then we will change the next pointer of last node from null to the new node. And then we will make the next pointer of the new node as null to show the end of the linked node. And here is a code to represent how to insert a node at the end of a linked list. And that is all for today's CAP activity.